Hey there, class. Mr. Prosky here. Hope you're having a good day so far. We're continuing with 3.4. The name of this lesson is Find and Use Slopes of Lines, and the essential question is how can we prove that lines are parallel or perpendicular? All right. So, we are going to do a warm-up here. It says use the slope formula to calculate the slope between these 2 points. Why don't you pause the video and see if you can write down the slope formula, and then I'll write it down in case you don't know what it is. Pause the video for a second. All right, if you're not sure what it is, the slope formula is m equals y2 minus y1 over x2 minus x1. Okay, so you got to label your points and see if you can calculate the slope for this. Go ahead. All right, let's go through this. So we label our points. I like to go x1, y1, and x2, y2. Okay, so we're going to plug into the formula. So m equals y2 is negative 10. Minus y1 is negative 5, so it's going to be minus negative 5, or chop, chop, and plus 5, over x2 minus x1 is negative 4 minus 2. All right, negative 10 plus 5 is going to be negative 5. Negative 4 minus 2 is negative 6. And when two negatives make a what? It's going to be 5, 6 will be our slope for this one. All right, sounds good. Okay, we have some definitions here. The slope is the slope of a non-vertical line is the ratio of the vertical change. I'll put change in y to the horizontal change in x. And in other words, instead of writing change, this symbol right here, this triangle is delta. That equals delta, and that literally means it's Greek for change. Okay, it's a Greek symbol for change. Or an easier way to think of slope is just what over what. It is rise over run. Okay? All right, so we're going to use some different colors here to kind of help us visualize this a little bit. On your paper, it might be hard to see which is what, okay? So, a negative slope is going to be this one right here, okay? It falls from left to right as in line J, okay? Why don't you guys go ahead and see if you can figure out the rest of these, okay? Figure out what the positive slope is, what the undefined slope is, and what the zero slope is, okay? Pause the video, see how you do. All right, the positive slope is going to rise. It rises from left to right. Which one rises from left to right? It's going to be this one, line K. Okay? So that's the positive slope. What's the undefined slope? Undefined slope, is it going to be horizontal or vertical? Undefined slope is vertical, so that's line what? That is line N. Okay, undefined slope is vertical. And the reason why it's undefined, so for example, if the rise, it's rise over run. So say the rise, it goes up 7, right? And the run, what's the run of a vertical line? Does it go left or right at all or no? It doesn't, so it's going to be 0. And then 7 divided by 0, you can't divide by 0, and that's why it's undefined. Okay, so 0 is in the denominator, that's why it's an undefined slope. Okay, sounds good. And then the last one we have is a zero slope. And a zero slope is going to be, the other one was vertical, this one's going to be horizontal. As in, which one is horizontal here? We have line L right there. Okay, and the reason why it is 0, because if it has, so the rise of a horizontal line is 0. It doesn't go up or down at all, but the run could be like 4. And what's 0 divided by 4? It's 0. It's a zero slope. Okay? It's an undefined slope. All right, sounds good. And then remember the formula. The formula is, slope is y2 minus y1 over x2 minus x1. Okay, don't forget that formula. All right, some of us struggle to remember horizontal and vertical lines, how to do that, and so we're going to have kind of a nifty little acronym to help us remember this here, okay? It's called HOI-VUX, okay? It's HOI-VUX. I'm going to draw a horizontal line here to separate them, okay? So the top is HOI, which is a horizontal line. 0 equals the slope. The O is actually 0, so the slope equals 0. And the equation looks like y equals a number, and it crosses the y-axis, okay? All right, and then V is a vertical slope. It's vertical line. It's an undefined slope. And then the equation is going to be x equals a number, and it crosses the x-axis. Okay? All right. So we have some different things going on here. So, okay, let's do example 1. We're finding the slopes of the lines in the coordinate plane. So we're going to do A and C for example 1. Then for checkpoint 1, you guys will find line B and line D. So let's do one together here, okay? And we're actually going to use slope formula, okay? So line A was this one right here, okay? There's line A. So we need 2 points that are on line A. Well, on line A, I see 0, 2 is one of them. And what's the other one? I see 4, 6. Okay, so we're going to plug into the slope formula. M equals, we got to label our points. Let me fix this actually. So we got x1, y1, x2, y2. So we're going to do M equals y2 minus y1 is 6 minus 2 over 4 minus 0. 6 minus 2 is 4. 4 divided by 4 is going to be 1. So the slope of this one equals 1. Okay. Why don't you guys go ahead and try C, B, and D. See if you can figure out the slopes of those lines. Give it a try. All right, let's do line C. Line C is this one right here. Okay, so line C, we have the point 0, 6, and we have 4, 6. And we're going to label our points x1, y1, x2, y2. So slope equals y2 minus y1 is 6 minus 6 over x2 minus x1 is 4 minus 0. 6 minus 6 is 0. 4 minus 0 is 4. What's 0 divided by 4? It is 0, so M equals 0 for this one. And we can tell that's a horizontal line that it's going to be a 0 slope. All right, line B. Line B is this one right here. Okay, what 2 points do we have for line B? We have 4, 6 again. And we also have 7, 3. So we're going to label our points x1, y1, x2, y2. You could also rearrange those. You could call this point right here x2, y2, and the other point x1, y1. You just got to be consistent. So, all right, M equals, we got to do y2 minus y1, so 3 minus 6 over x2 minus x1 is 7 minus 4. That's going to be negative 3 over 3. So M equals negative 1. Negative 3 divided by 3 is negative 1. And then the last one, line D. Line D, let's use a different color here. Do we have 1, 2, 3? Green, blue. D is this line right here. And the points we have are 4, 6 again. And we also have 4, 0. It's a vertical line, so hopefully you can tell what the slope's going to be, but we'll still plug it in here just to figure it out. So we got to label our points x1, y1, x2, y2. So we got 0 minus 6 over 4 minus 4. 0 minus 6 is negative 6. 4 minus 4 is 0. So this is the slope for this one is undefined. You'll recall that vertical lines are undefined slope. Okay? All right, now, this is also kind of a review from Algebra 1. So, slopes of parallel lines. Okay? Slopes of parallel lines. Parallel lines have the same slope. And need to, we're going to put vertical. It's going to go in that blank. We don't have room. Vertical or horizontal lines are parallel. Okay? And then perpendicular lines. What's the slopes of perpendicular lines? We're going to put just perpendicular here, but basically, so slopes parallel, actually let's use the parallel symbol. Parallel equals same slope, and perpendicular equals what kind of slopes? Opposite reciprocals. Okay, slopes. Okay, that's the important thing. You can look at a thing here and you can tell if they're going to be the same or opposite reciprocals. Now let's review what opposite reciprocals means. What's the opposite reciprocal of 1/7? Well, you're going to flip the fraction and change the sign. So 1/7 becomes 7/1, and the sign is positive, so it becomes negative, right? What's the opposite reciprocal of -5/6? Well, you would flip the fraction, which would become 6/5, and the sign would change, so it would become positive 6/5. So that's what we mean by opposite reciprocals, okay? All right, so let's figure out if these lines are parallel or not. Okay, so let's do it. So, let's figure this out here. So we're going to do the blue. I have the blue line here. You can't really see that on your paper, but okay, let's find the slopes of the lines here. So we have, for the blue line, we have -1, 3, and we have 0, 5. So we're going to label our points. We're just going to figure out if the slopes are the same or if they're opposite reciprocals, okay? So we have x1, y1, x2, y2. So we're going to plug in m equals y2 minus y1 is 5 minus 3 over x2 minus x1 is 0 plus 1, which is going to be 2/1, which equals what? Equals 2. So these are going to be parallel. They should be the exact same slope, right? Now this red line right here, what's the coordinates of the red line? We have 2, 4, and we also have 0, -2. So again, we label our points x1, y1, x2, y2. So we're going to do m equals y2 minus y1 is -2 minus 4 over 0 minus 2. So m equals -2 minus 4 is -6. 0 minus 2 is -2, which equals 3. Now, are these slopes the same here or no? They are not. So are these parallel or not parallel? These are not parallel because they're not the same slope. And that's all you have to do. Okay, why don't you guys try checkpoint 3 and give it a try. All right, sounds good. So we have 2 points here. We have, so it was 2, -2, and 5, 7. And we're plugging in, we're going to do our slope formula. We're going to figure out if these are parallel or not. x2, y2. So m equals 7 plus 2 over 5 minus 2. So that's going to be 7 plus 2 is 9 over 5 minus 2 is 3, which equals 3. So the slope of the other one should also be 3 if they're going to be parallel. So then we had -3, 4, and 1, -8. So we got x1, y1, x2, y2. So we're going to plug in here. So we have y2 minus y1 is -8 minus 4 over 1 plus 3, which is -12 over 4, which equals -3. Now, are these parallel lines? Are they the exact same slope? Well, we have 3 and -3. Those are not the same slope. So these are not parallel because they're still not the same slope. They have to be the exact same number, not positive or negative. Okay, sounds good. Now we're doing the same kind of thing, but we're checking whether these lines are perpendicular. And if you recall, the slope should be opposite reciprocals if that's the case. Why don't you guys pause the video and give it a try. All right, let's do it here. Let's do the blue line first. So we have 0, 5, and we have -2, -3. So we got x1, y1, x2, y2. So we got m equals y2 minus y1 is going to be -3 minus 5 over -2 minus 0. So m equals, that's going to be -8 over -2. So m equals, what's that going to be, 4? So the slope of the other line should also be 4 if these are going to be perpendicular. Actually, it should be the opposite reciprocal of 4. What's the opposite reciprocal of 4? Should be -1 over 4. Let's see if that's the case. So then we have -8, 0, and we have 0, -2. So we're going to plug in m equals x1, y1, x2, y2. So we have -2 minus 0 over 0 plus 8, which is equal to -2 over 8. And if we reduce that, what do we get? -2 over 8 equals -1 over 4. 2 goes into both 2 and 8. So are these perpendicular? Lines? They are. These are opposite reciprocals. Oh no, I'm sorry. So it says determines if they are the problem is kind of goofed up here, but these are perpendicular lines. So these are perpendicular because they have opposite reciprocal slopes. Okay, so that means they're perpendicular because they have opposite reciprocal slopes. All right, if you want to try checkpoint 4, you can go ahead and do that. Go ahead and give it a try. All right, so for checkpoint 4, we should have had the slope of the first one would be 2 minus 0 over 0 plus 4, which equals 2 over 4, which equals 1/2. And the slope of the other line should have been m equals negative 2 minus 4 over 0 plus 2, which equals negative 6 over 2. So m equals 3, or negative 3. Now, are those lines perpendicular? They are not, because we have 1/2 and negative 3. So this is going to, these are not, so no, not op recip slopes. Okay? So that is why they are not perpendicular. All right, the last thing is a little tricky, but just stay with me here, okay? These last 2 examples are kind of important and kind of tricky. So we are drawing, it says draw a perpendicular line. It says line H passes through 1, negative 2, and 5, 6. 1, negative 2, and 5, 6. It says graph the line perpendicular to H that passes through 2, 5. Okay, so here's what we're going to do. I would first graph line H, okay? We're going to graph line H. I'll use blue for that, okay? So here's line H. So it passes through 1, negative 2, so we go right 1, down 2. And we do 5, 6. 1, 2, 3, 4, 5 to the right, and up 6. 1, 2, 3, 4, 5, 6. Okay, so I'm not going to be able to draw a perfect line, but I'll do the best I can. So there's the line right there, okay? All right, so now, here's what we need to do. We're trying to graph the line perpendicular to H that passes through 2, 5. So the way to do that is to calculate the slope of line H first, because that's gonna determine like what kind of slope we need for the new line, okay? So let's use rise over run here, okay? So I'm gonna start with, so we have these 2 points here. I'm gonna start with this left-hand point. I'm gonna go up until I get level with that point. How many boxes was that? 1, 2, 3, 4, 5, 6, 7. That was 8, and then over how many? It is over 4. So our the slope of line H equals 8 over 4, which equals what? 8 divided by 4 is 2, okay? So we want the slope of the perpendicular lines. We want m of the perpendicular line, okay? So what does that mean? If the perpendicular line, is that the same slope or the opposite reciprocal slope? It should be the opposite reciprocal of 2, right? What's the opposite reciprocal of 2? It's going to be negative 1 over 2, okay? I'm going to write op recip of 2. That's where that came from, okay? So now what we can do is now we can graph the new point, which is 2, 5. So we go right 2 up, 1, 2, 3, 4, 5. And now our slope is telling us to go down 1, right 2. So we can go down 1, right 2, down 1, right 2, all the way across. And we can go up 1, left 2 to go the opposite direction, okay? Oops. So we can go the exact opposite direction. And now we can connect this. You can see it's going to make a nice perpendicular line right here, okay? All right, so the trick is graph the 2 points from the original line. You're going to find the slope using rise over run. Let's write this down, actually. I'm going to write it down here, okay? So step 1, okay? Step 1 is graph the first line. Step 2, find slope. And I want you to put rise over run. Step 3, determine, if we want parallel or perpendicular line. Okay? Parallel line, we want the same slope. And perpendicular line, we want the opposite reciprocal slope. Okay? All right. And step 4, use that slope to do rise over run and find other points. Okay? All right, so that's the steps here. So that's what we did for that last example. If you want to pause the video and try the checkpoint, give it a try. Otherwise, we'll go through it in a second. Okay, so we had this example here. We have line J. Line J we'll highlight in green here. So line J passes through 1, -2. So first thing we do is plot the lines. We got right 1, down 2. Then we have 5, 6. We go right 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, 6. Okay, we graph the line again. And all right, now we need to find, so we graph the line. Next thing we need to do is calculate the rise over run. So here's our 2 points. So rise over run, we're gonna go up to get level with this one here. I'm gonna go over, so that's up 1, 2, 3, 4, 5, 6, 7, up 8 and over 4. So the slope M of line J equals 8, upright rise over run is 8 over 4, which equals 2. And now we want the slope of the parallel line, right? It wants us to find the parallel line, so we're going to do this. Okay, is the parallel line going to be, is it going to be the same as 2 or the opposite reciprocal of 2? It's going to be the same as 2, so we're going to write 2. Same as, well, let's write same M as 2, okay? All right, so we're going to graph through point 0, 1. So we go up 1, put a point, and our slope is 2 or 2 over 1, right? So we go up 2 over 1, up 2 over 1, up 2 over 1, all the way across. Go down 2, left 1, all the way across. And you can see it's going to make a nice parallel line here. Okay? And that's why that lines have the same slope, never crosses, because they keep going up and over by the same amount. All right, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.